Hello everyone, welcome to Code and Learn. Since we are building a Redis server, in this video we are going to talk about the TCP server that we are going to use for accepting and managing connections. A Redis client would connect to the Redis server by creating a TCP connection to its ports. The default port is 6379, while REST, which is the protocol used between the client and the server, is technically non-TCP specific. The protocol is used with TCP connections or similar stream-oriented connections like Unix socket in context of Redis. When we are going to create the TCP server in Go, we need to keep in mind a few things. The first thing is handling connections. Our TCP server must accept incoming connections from the client. This will be often done in a continuous loop. When a client connects, you will use accept to create a new socket dedicated to that specific client and its address. The original socket will remain open to accept more clients. We don't need to worry about the underlying sockets and how this works because Go provides a very good package support for working with TCP connections. Along with handling connections, we need to manage concurrency as well. A server that only handles one client at a time isn't very useful, is it? You need to implement a strategy for handling multiple clients concurrently. In our project, we are just going to create a new Go routine since Go routines are cheap and this is how Go implements concurrency. We also need to consider graceful shutdown. That is, when we are closing the server, we need to make sure that any connection that's ongoing should be handled gracefully. Again, all this is provided by the net package, which is part of the standard Go library. If you want to look at the documentation, you could go at this link to have a look. So to start, you will use net.listen to create a listener. As you can see, we are specifying the TCP protocol and a localhost address. This function binds to a specific address and port and begins listening for incoming connection. As you can see, a common practice is just using 0000 as the IP address, which listens on all network interfaces. If there's any error listening, we will handle that error gracefully. Otherwise, this listener will be created and we can defer close it to make sure that resources are given back to the OS. So once you have a listener, you will create an infinite loop to continually accept new connection. So this loop here is running infinitely and we are going to accept connections inside the loop. The listener.accept method will block until a new client connects, at which point it returns a net.connection object representing the connection. So this way we can handle multiple connections. As mentioned earlier, a TCP server needs to handle multiple clients connections simultaneously. This is where Go routines become essential. Instead of processing each connection sequentially in the loop, which will mean we only accept one connection, process it, before accepting a new connection, we will use an approach like this. We will spawn a new Go routine for each new connection that we accept. This allows the server to continue listening for new clients while also handling the existing one in a new Go routine. Next, once we accept the connection, the net.con object is an interface that combines IO reader and IO writer. This means we can use familiar functions like io.copy or simply read by providing a buffer to the connection object. When we are providing a buffer, we are reading data in chunks using the buffer. Here, if we are getting EOF, that means the connection was closed and we can return gracefully. Similar to this, we can also write back data using con.write, which accepts a byte slice. So these are the few things we need to keep in mind when working with the TCP connection in Go. In the next video, we are going to write some code to start our basic TCP server that is going to listen to connections in a Go routine and process them. I hope you liked the video. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding!